Google's new chip, called Willow, is being described as more than just a cool tech upgrade. It could completely change how we solve some of the world's biggest problems. The buzz in the tech world isn't about a new iPhone or social media trend this time. It's about a chip that might have just rewritten the rules of computing. Willow is a next-generation quantum processor created by Google. It's so advanced that it made many scientists take a step back and rethink what quantum computing is really capable of. This chip didn't just beat regular computers in speed, it did something even more impressive. It produced results that were actually reliable. That's a big deal because quantum computers are usually fast but very unstable. When Google introduced Willow in December 2024, they didn't make a big announcement. There was no flashy event or press release. Instead, it appeared quietly, almost like something out of a science fiction movie. What made Willow stand out was that it had over 105 logical qubits. These aren't just physical components, but special error-corrected ones. That means the chip could fix its own mistakes during calculations, something that has been very hard to do at this scale. Inside the chip, over 1,000 physical qubits work together using quantum error correction, a method many experts didn't think was possible to use effectively on this level. Other companies like IBM and Rigetti have been working on similar technology, but often ran into serious problems with noise and instability. Willow, somehow, managed to avoid these issues. In fact, as Google added more qubits, the system became even more stable, which completely surprised researchers. Normally, adding more parts to a quantum system makes it more error-prone, not less. Willow showed that it wasn't just about being fast, it was about being trustworthy. And in quantum computing, that's the key to unlocking real power. If a quantum machine can deliver consistent, correct answers, it can solve problems in medicine, cybersecurity, energy, and climate science in ways traditional computers never could. We're talking about solving tasks in minutes that would take supercomputers thousands of years. The chip also raised serious concerns. One of the biggest is its potential to break modern encryption, systems that protect your bank, your data, and even government secrets. That's how powerful this chip could be if it works as Google says it does. Google didn't keep this secret. They published their results, shared how they built it, and provided proof that convinced experts the future of computing had suddenly arrived much earlier than expected. Military groups, governments, and tech companies all began paying very close attention. For a few weeks, Willow was everywhere. Scientists quietly talking about it, tech experts praising it, headlines calling it the start of a new era in computing. And then, just as suddenly, it all stopped. Google went quiet. No updates. No follow-ups. Just silence. And that silence might be the most unsettling part of all. After Willow was introduced, the excitement didn't last long. The follow-up events, flashy demos, and bold claims all faded away quietly. The excitement around this powerful new chip disappeared almost as fast as it had arrived. Google moved on without saying much. Their quantum computing blog stopped updating. The researchers and experts who had once spoken proudly about Willow just stopped talking about it. So what really happened? Was there a technical issue? Did something go wrong behind the scenes? Or did Willow reveal something so unexpected that even Google wasn't fully prepared to explain it? That's the mystery that still hasn't been solved. To be clear, Google never officially shut down Willow. The chip wasn't destroyed or hidden away in a basement. According to the last confirmed reports, it still exists and remains part of Google's quantum research efforts. But since its announcement in December 2024, something strange has followed: complete silence. And in the tech world, silence often means more than words. Normally, when a major company like Google makes a breakthrough, they follow it up with a lot of media attention. Press interviews, live demos, technical papers, and updates to attract investors, partners, or new researchers. That's exactly what happened in 2019, when Google unveiled its Sycamore quantum processor and claimed to have reached quantum supremacy. The tech world exploded with interest and discussion. But with Willow, things were different. After the first announcement, nothing more came out. No big conference talks, no working demos, no real-world tests. Google's quantum AI team didn't share any new milestones either. That's very unusual, especially for something as groundbreaking as Willow. Now, just because a project goes quiet doesn't mean it's been abandoned. In many cases, it actually means the opposite. When a technology is considered highly sensitive, either because of its scientific importance or its potential political impact, companies and governments often stop talking about it publicly. They take it behind closed doors to avoid drawing too much attention. Quantum computing is especially vulnerable to this kind of silence. One of the biggest reasons is its ability to break encryption. If a quantum computer is powerful and stable enough, it can crack the complex math that protects most of the world's data, from bank accounts to government secrets. This isn't a science fiction idea. It's a real and well-known risk. Experts and agencies like the NSA in the US and cybersecurity departments in other countries have warned about what they call Q-Day. That's the moment when a working quantum computer becomes strong enough to break today's encryption. Willow didn't reach Q-Day, but it showed that we're getting close. Before Willow, people thought that kind of power was still 30 years away. But after seeing what Willow could do, some now think it might be only 5 to 10 years away. That was enough to raise alarm bells. Although there are no official documents saying so, it's very likely that once Willow was released, the project was placed under closer observation by authorities. In the US and many other countries, when a new technology shows signs of being important to national security, it often goes through private reviews. Google has worked with government agencies in the past, including DARPA and the Department of Energy, so its quantum team would be very familiar with how serious things can get when technology moves into this kind of territory. In short, Willow may have revealed something bigger than anyone expected. And the silence that followed might not be a sign of failure, but of just how powerful and sensitive this breakthrough really is. It's very likely that after the unveiling of Willow, Google's powerful quantum chip, things moved behind closed doors. Given what Willow could do, it probably became the subject of private discussions, careful reviews, and risk assessments, not just within Google, but also with governments, global organizations, and possibly international allies. These aren't the kinds of conversations that are announced to the public. There's no press release for "we're deciding if this tech is too dangerous to talk about yet." There's also a strong chance that rival tech companies responded quickly. In the competitive world of quantum computing, solving even part of the quantum error correction problem is a major breakthrough. It gives a company a serious edge. In situations like this, companies might choose to stop sharing updates, either to protect their lead or to avoid tipping off competitors. That may explain the sudden silence around Willow. The chip is likely still being studied and developed, but now it's happening quietly, away from public attention. It's important to remember that Willow wasn't created to be sold or installed in everyday devices. It's not something you'll ever use on your laptop. It was built as a research prototype, an experiment to explore what might be possible with quantum technology. But what it represents is far bigger than the chip itself. In every major tech field, there's a moment when a project moves from being just a prototype to becoming the foundation of a new kind of platform. For classical computers, that moment came with the invention of the microprocessor. For AI, it was the development of deep learning and transformer models. And for quantum computing, Willow might be that moment. Not because Willow is perfect or ready for the mainstream, but because it reached a level of capability that forced a shift in priorities. At this level, control, secrecy, and global impact become more important than publicity. Google understands this very well. The company has worked closely with US government research agencies in the past, including DARPA and the Department of Energy. So it's not surprising that they would treat a sensitive breakthrough like Willow with extra caution. There could be patents filed, private partnerships formed, and ongoing experiments, all kept out of the spotlight for now. But what exactly made Willow such a big deal? The answer comes from a problem Google gave Willow to solve. It was based on a complex mathematical test known as random circuit sampling. This wasn't a flashy demo or public show. It was just another routine benchmark for quantum computers. The task was incredibly hard. So hard, in fact, that even the world's most powerful classical supercomputers would take longer than the age of the universe to finish it. We're talking about quintillions of years. But Willow did it in under 5 minutes. That speed alone was amazing. But the real surprise came when scientists looked deeper. Willow didn't just solve the problem quickly. It did it accurately. As they increased the number of logical qubits, quantum bits, something incredible happened. The number of errors actually went down. This is completely different from what usually happens in quantum systems. Normally, more qubits mean more noise, more instability, and more errors. But with Willow, adding more resources made the system more stable. This is called exponential error suppression, and it's the key to what scientists call fault-tolerant quantum computing. For years, researchers had only dreamed of reaching this level. Willow showed that it was actually possible. It wasn't just fast, it was trustworthy. And that matters a lot. In fields where precision is everything, like decoding quantum states or modeling physical systems, you can't afford mistakes. Willow was able to deliver accurate results, over and over again. That kind of reliability is what researchers have been waiting for before they take the next big steps in quantum computing. This breakthrough didn't just change hardware. It changed how experts thought about the future. If a chip with just over 100 logical qubits could get more stable as it scaled, then larger quantum systems might follow the same path. That means we're not decades away from solving big, real-world problems. We could be just a few years away. Google's team described Willow as stepping into a whole new category of computing power, a platform that could manipulate entangled quantum states with high precision and confidence. That level of control allows it to model and calculate things classical systems simply can't. It's not just about faster calculations. It's about replacing guesswork with certainty. Willow's ability to reduce randomness and unpredictability into something accurate and usable is what sets it apart. At that point, the question stopped being, can we build this? And became, are we ready to handle what comes next? Because once uncertainty itself becomes something you can program and control, everything changes. And that's the future Willow pointed us toward. We don't argue anymore about whether quantum computers can solve tough encryption problems. That's already accepted. The real question now is whether we have the laws, ethics, and public discussions in place to deal with what comes next. Google's Willow quietly brought this issue to light. It didn't make a big announcement or dramatic presentation, but what it showed was impossible to ignore. Things that used to sound like science fiction or philosophical ideas are now becoming real engineering challenges. This shift affects many important areas. For example, secure communication that depends on encrypting data using huge prime numbers might not be secure much longer. If quantum computers that can correct their own errors become reliable, they might be able to break these protections in just hours instead of years. Leaders in business, government, and national security are now aware of this. What used to be a future problem is now starting to feel urgent. Even though Willow didn't produce a product you can buy, it changed the direction of quantum computing research. It caused the tech world to rethink how soon powerful quantum systems might be ready. Suddenly, systems that can crack huge mathematical problems didn't seem decades away. They seemed possible in less than 10 years. After Willow's breakthrough, companies became quieter in public, but their internal planning and meetings picked up speed. Willow hadn't failed. It had passed a major test. That success made scientists and institutions take the situation more seriously. Willow showed actual proof, not just theory. With enough quantum bits, called qubits, and good enough error correction, a quantum computer can complete tasks that regular supercomputers can't. This wasn't just about computing speed, it had effects across different fields. Medicine, shipping and logistics, finance, and chemical research could all be transformed. Simulations for designing new medicines, planning global supply chains, or managing risk in markets could suddenly become faster and more accurate. But with great promise comes great responsibility. If Willow is a step toward building powerful quantum machines, then we must learn how to control who gets access. The scientists made it clear, Willow didn't break real-world encryption. It didn't unlock anyone's secrets. But it did change how we think about the future. Problems that used to seem hundreds of years away might now be solvable in our own lifetimes. That's why Willow's demonstration wasn't just exciting, it also made people stop and think. It reminded everyone that we can no longer predict what's coming next with confidence. Not because a machine told us the future, but because this technology is now capable of shaping it. Once enough qubits work together with strong error correction, we can program things that were once impossible. Comparing this to past inventions helps put it in perspective. The nuclear bomb wasn't built to scare people, but once it was used, the world had to face a new reality. Gene editing tools weren't made to rewrite nature, but they gave us that power. Willow did the same for computing. It wasn't about science fiction, it was about making people realize how close we are to a new kind of future. By running trillions of error checks and complex operations, Willow proved that reliable quantum computing is no longer just an idea, it's now physically real. What was once an experiment is becoming a guide for building systems with massive potential. The task Willow performed wasn't unusual, but the result was. It changed what people believed was possible. It raised concerns about when this tech will become mainstream and how prepared we are to handle it. Willow exposed a big gap, not in scientific ability, but in how governments and institutions plan to manage such powerful tools. Willow turned something routine into something revolutionary. Now, we are at the point where quantum machines might soon tackle problems no traditional computer ever could. The question isn't if anymore, it's when, and more importantly, are we ready? Willow didn't begin as a public launch or a gadget for consumers. It was a private project deep within Google's advanced research labs. It was built during a quiet race among major tech companies to create a working and scalable quantum computer. This wasn't about making faster computers. It was about changing how computing works altogether. For Google, Willow marked the point where theory became working hardware. What made Willow different wasn't just that it was a quantum machine, but how it produced results in ways that were hard to explain using current understanding. Early comments from insiders hinted that Willow didn't just reach a new goal. It broke past limits that experts thought couldn't be crossed. Everything about it was different. Its problem-solving speed, its design, and Google's decision to keep much of the technical information secret. Instead of introducing Willow through detailed research papers or a major product launch, Google chose to show it off just once in late 2024. In that single demonstration, Willow solved a problem known as random circuit sampling. A task so complex that a classical supercomputer would have taken longer than the age of the universe to complete it. Willow finished it in just minutes. This wasn't just about speed. It was about doing something that was thought to be impossible in any practical amount of time. That moment changed how people thought about what machines could actually do. Quantum physics has always been hard for people to fully understand. Concepts like particles being in many states at once, or being connected across long distances, don't feel natural to us. But Willow turned that strange world into something we could program. It made uncertainty something you could write instructions for. And once you can not only face complexity but control it, everything starts to change. The future becomes less about guesses and more about equations, even if we don't fully understand them yet. This is why Willow is seen by some experts as a threshold technology. That means it doesn't just help us do things better, it changes what it means to do something at all. We've seen this before with nuclear energy, gene editing, and artificial general intelligence. These kinds of breakthroughs don't just improve technology. They force society to reconsider its values and systems. Willow joined this group the moment it entered a level of ability where we could no longer test or fully grasp its output using classical systems. Because of this, the focus on Willow shifted from just research labs to much higher levels. Ethical boards, government agencies, and even military groups started asking what Willow might become. Not because it was instantly dangerous, but because it changed the power structure. A system that can understand and process more complex problems than groups of human experts working together is a serious development. Because Willow isn't just about finding faster answers. It's about discovering questions we haven't even thought to ask, and getting answers we might not yet be ready to understand. So, what do you think Willow means for the future of technology, science, and even human decision-making. Are we entering a new era of computing that we haven't fully prepared for? Let us know in the comments. Don't forget to like, share, and subscribe for more content like this. Thanks for watching, and we'll see you in the next video.